So in the last video, we talked about exponential properties and we proved a bunch of them. In this one, we're going to apply those exponential properties to simplifying an exponential expression. So a quick reminder, if you have a to the x, right, the x is our exponent, and the a is our base, okay? Okay, what does simplifying an exponential expression mean? There are three things that you need to do. The first thing is you want to get rid of all parentheses. The second thing, you only want one of each base, and this will make a lot of sense when you start seeing exponential expressions. And the third thing, no negative exponents. So when you see an exponential expression and your goal is to simplify it, you are going to follow this checklist. And if you follow this checklist, you're good, okay? If all three of these things can be checked off, then you have completely simplified. So what we're going to do is we're going to go through a whole bunch of examples because that's the best way to learn. And I would like to emphasize that there's not only one way to do each of these, okay? But what I'm going to show you is a foolproof way, okay? Something where it always works in this order. Whereas if you do it in a different order, you might be creating extra work for yourself, but you're welcome to do it in any order that you want. So let's take some examples and just work through. So let's start with a to the negative 2, b squared to the 5th power. Okay, so now this is going to make sense, right? Because we see parentheses, so automatically we know that we're not done. Certainly, we have one of each base. I only see one a here. I only see one b here, so we have one of each base. But we still have negative exponents, so we're not completely simplified. Okay, you should work in this order. So you want to get rid of parentheses first, then make sure that you have one of each base, and then get rid of negative exponents. If you go in that order, you will always finish with the least number of steps. It's the most efficient order, and you'll also always reach that simplification pretty quickly, okay? So the first thing that we want to do is get rid of parentheses. Well, to get rid of parentheses, you always do it in one way. You're distributing. Okay, so we can distribute the parentheses, and distributing the parentheses means not really distributing the parentheses, distributing the exponent. And we know from the properties of exponents that when we distribute, we multiply the exponents. So this a to the negative 2, b squared, becomes a to the negative 10, b to the positive 10. And I'm actually going to rewrite this in red so that you can distinguish the problem from the solution. Okay, and there's a negative here. So what did we do here? We distribute the exponent by multiplying. This is always the case. And the idea is that we get rid of parentheses first. Okay, now in this case, we already have one of each base, so we don't have to worry about that. That'll be for a future problem. What we need to do is we need to get rid of the negative exponent. Now, this is actually a really simple process, okay? I'm going to do it in the one step here, and then underneath it, I'll explain it in 2 steps. When you have a negative exponent, we know that when it goes into a denominator, it turns positive. So we could take just the a to the negative 10 and put it into the denominator, making it b to the 10 over a to the 10. And this would be our final answer. So I'm going to take a second and just break that down, okay? So first of all, what we did here is we got rid of negative exponents. By moving them into the denominator. And you have officially finished this problem. So let's do a side note. So first of all, a to the negative 10, b to the 10. If you were to treat this as 2 separate things, then we're saying a to the negative 10 is the same thing as 1 over a to the 10 times b to the 10, and we have fractions. Let's turn that into a fraction too. So a to the negative 10 is the same thing as 1 over a to the 10. B to the 10 is the same thing as b to the 10 over 1. When we multiply fractions, we multiply straight across. So this is just a short way of showing that you get b to the 10 over a to the 10. Okay, also a side note. If you have 1 over a to the negative x, so if you have a negative exponent in the denominator, that is the same thing as moving it to the numerator and making it positive. Okay, so 1 over a to the negative x is the same thing as a to the positive x. Quickly, the reason why is that this would be 1 over, and then we know that a to the negative x is 1 over a to the x. And what we do when we have fractions within fractions is, I'll put this in green. To get rid of a fraction within a fraction, we don't want a fraction in the denominator. So what we can do is we can multiply by a to the x over 1. And that will cancel the a to the x's. But what we do in the denominator, we have to do in the numerator, so that we don't change the value of the fraction, because this would be like multiplying by 1 over 1. Okay, so 1 times a to the x over 1 is just a to the x. Okay, and the whole point of showing you this is so that you know if you have a negative exponent in the denominator, to make it positive, you just move it to the numerator. Okay, so in other words, 1 over a to the negative 5 is the same thing as a to the 5th. So just two separate notes. Okay, we're ready for another example. So let's say that we have a squared b to the negative 1 to the negative 1 power over a to the negative 4b. Okay, what do we do first? Well, we go back to this. First, we want no parentheses. Well, to get rid of parentheses, we distribute. These are our parentheses. We can distribute the negative 1. If we distribute the negative 1, we get a to the negative 2, b to the positive 1, over a to the negative 4b. Okay, and notice if we have b, that's just b to the first power. Okay. What did we do here? Again, we distributed the exponent by multiplying. This gets rid of parentheses. So your first step is always going to be distribute to get rid of parentheses. Okay, next step. Well, this is a case where we don't have one of each base. So that's the next thing that we're going to take care of. Now, if you notice, we only have one of each base in the numerator and one of each base in the denominator, but now we need to combine it. So we combine the bases vertically. Well, to combine the bases vertically, we know if we have the same base, we can combine it by subtracting the exponents. Okay, so a to the negative 2, we're divided by a to the negative 4. What we're really doing is negative 2 minus negative 4. Negative 2 minus negative 4 is 2. And these cancel each other out, right? 1 minus 1 is 0. So our answer here is a squared. We're done. We have no negative exponents, no parentheses, one of each base. And yeah, the b canceled. That's fine. So we combined the bases. Vertically by subtracting exponents. And that's it. Okay, next problem. B to the negative 4 c squared divided by a to the negative 4 b to the 8th c to the 1st, and we're going to raise this to the negative 3rd power. And as soon as you feel like you've gotten the hang of this, I would suggest that you pause the video, do it on your own, and then restart the video. Okay? Okay, so we have parentheses. We know the first thing that we do is we get rid of the parentheses by distributing the exponent. And the exponent gets distributed to every single exponent here. And we multiply. 5 times negative 3 is negative 15. B because negative 4 times negative 3 is positive 12. C to the negative 6. A to the positive 12. B to the negative 24. And C to the negative 3. Negative 3. Again, what did we do? We distributed the exponent. Again, to get rid of parentheses. Okay, so now you're going to check for one of each base in the numerator and one of each base in the denominator. We have that. So again, we just need to combine vertically. To combine vertically, we subtract the exponents. Negative 15 minus 12 is negative 27. 12 minus negative 24 is 36. And negative 6 minus negative 3 is negative 3. What did we do to get this? We combined vertically. That means that we subtracted the exponents. Okay, we have one more step because there are no parentheses. We have one of each base, but we still have negative exponents. Well, to get rid of the negative exponents, we just move anything that's negative into a denominator. So that means b to the 36 remains in the numerator because it's positive. But the a needs to move to the denominator in order to make it positive. And same thing with the c. So we have a to the positive 27 over, and it's c to the positive 3 in the denominator. And what did we do? We got rid of negative exponents. Notice the process is exactly the same as it was for the last one. And we're done. No negative exponents, no parentheses, one of each base. Okay, next one. These are going to look more complicated, but they're not because you're going through the same process over and over again. So this one, a b squared over a cubed c, and we're going to square this, times a to the 5th b cubed c to the negative 2 over a to the negative 6 b times c to the 5th, and we're going to raise this to the second power. Okay, and this looks complicated. It's not. It's no different than any of the others that we've done. There's one extra step in here. This is the most complicated it will get. Okay, so notice we have parentheses. To get rid of the parentheses, we distribute the exponent. Nothing changes. So what do we get here when we distribute the exponent? We get a squared b to the 4th over a to the 6th c squared. So this was a c to the 1st multiplied by 2. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. 3 times 2 is 6. Now we're going to do the same thing here. So we get a to the 10, b to the 6th, c to the negative 4 on top, On bottom, multiply the exponents by 2, a to the negative 12, b squared, c to the 10th. Okay, what did we do? We just distributed exponents. Okay, what comes next? This is the only part that's separate. So first of all, when you're multiplying fractions, you essentially multiply straight across. So essentially what we're doing is we're just extending this line. It's one fraction. Here's the extra step. In all of the others, we only had one of each base in the numerator and then one of each base in the denominator. Here we have multiple a's. There's an a squared and an a to the 10th and a b to the 4th and a b to the 6th. Okay, and then in the denominator, we see two a's and we see two c's. So we need to combine those horizontally before we combine vertically. So in order to combine horizontally, we know if we're multiplying with the same base, we add the exponents. So a squared and a to the 10 can be combined by adding the exponents and making it a to the 12th. So we have a to the 12th. The b's can be combined. In the numerator, we have a b to the 4th and a b to the 6th, which makes it a b to the 10th. And there's only one c. So we get c to the negative 4. And now we're going to do the same thing on the bottom. We have an a to the 6th and an a to the negative 12. That combines. 6 and negative 12 is negative 6. And we have a c, the b we can leave. And the order here doesn't matter. I'm just putting it as ABC just for my own benefit. So I'm going to put the b squared next. If you put the c next, that's fine. So the c squared and the c10 combined, we add the exponents, it becomes c to the 12th. So we have been combining vertically, we subtract. Now we needed to combine horizontally first. So I would always combine horizontally before you combine vertically. Otherwise, you might have to combine vertically more than once. Okay, so we combine horizontally first. And this is always by adding exponents. Okay, and now we're up to the part where we have one of each base in the numerator, one of each base in the denominator. We can combine vertically. 12 minus negative 6 gives us a to the 18, b to the 10 over b to the squared. We subtract. 10 minus 2 is 8. And negative 4 minus 12 gives us negative c to the negative 16. So here we combined vertically, that we subtract. And the only thing left to do is to get rid of negative exponents. So the power of a is positive, so it stays in a numerator. Same thing with the power of b, stays in a numerator. The power of c is negative, so we move that to the denominator. And this is our final answer. And again, you can see that our last step was to get rid of our negative exponents. So it's a 4-step process. That's it. This is as complicated as it gets. You distribute, you combine vertically, combine horizontally, and then get rid of negative exponents. So let's do that again. Let's do another example. We'll do 2 more. So we have 2 e to the 5th b to the negative 3 power over a cubed b c to the 10 times a squared b to the 4th over a c to the negative 3. Okay, I would encourage you to, again, stop the video, try it on your own, and then you could start the video again. The only thing that's different here is this 2, okay? So this 2, you want to treat it like any other variable. Treat it like a d, okay? Because that's what it is. So treat it like a d, and then you can deal with evaluating it later, okay? It works exactly the same thing. So the only difference is what people do. The most common mistake is that they multiply, but the 2 is like a base, okay? That's why I say treat it like a d. You're raising it to the negative 3 power. So in our first step, when we distribute, you're distributing the negative 3 to the 2 as well as a power. So everything that we do is exactly the same. So we're going to do 2 to the negative 3, because if this had been a letter, it would have been to the negative 3 power. A to the negative 15, we're just multiplying. B to the 9th, C to the negative 6, over, that's it. There's nothing else to distribute, right? So it's just A cubed, B, C to the 10, this 3, this negative 3 only applies to this set of parentheses, okay? And then times, and there's a parentheses there, but there's no exponents. We don't actually have to do anything with that. So it's just a squared b to the 4th over a c negative 3. And remember that this is like one line. Okay, so what did we do? We distributed the exponent. Now we keep going. We said the next thing to do is to combine horizontally. So we combine horizontally. That means that we add the exponents whenever we have 2 of the same base. So we have an a to the negative 15 and an a squared. We have to add the exponents so that we get only one a. So we have 2 to the negative 3, a negative 15 plus 2 is negative 13. And then 9 plus 4 is positive 13. C to the negative 6. Over 3, and this power of a is 1. So 3 and 1 is 4. So we have an a to the 4th. There's only one b. And then we have a c to the 10 and a c to the negative 3. So 10 and negative 3 is 7. Okay. So what did we do? We combined vertically. Sorry, we combined horizontally, which means that we added. Okay, so the next thing is to combine vertically. So we have 2 to the negative 3. Then we have a to the negative 13 and a to the 4th. Well, negative 13 minus 4 is negative 17. Then we have a 13 and a 1. 13 minus 1 is 12. And we have negative 6 minus 7, which is negative 13. So we combined vertically, which means that we subtract. Okay. Last thing to do is to get rid of negative exponents. So the b to the 12 stays in the numerator. The rest of it is negative. So it becomes 2 to the positive 3. 2 to the positive 3 is 8. And I'll put a little note there. Then we have a to the positive 17 on bottom, c to the positive 13 on bottom. And this is it. No negative exponents, no parentheses, one of each base. So we got rid of negative exponents. And I did this in one step. You can do it in two. You could have written, instead of an 8, a 2 to the positive 3. So 2 to the negative 3 is equal to 1 over 2 to the positive 3. This is where the 8 came from. 2 to the positive 3 is just an 8. Okay, so that's where this 8 came from. The 8 down here came from the 2 to the negative 3. 2 to the negative 3 puts an 8 in the denominator. Okay. Okay, let's do one last one. So, number 5. Sorry, my computer is very slow right now. Number 6. Four times a cubed b to the negative 1 c squared over a to the 5th b. I'm going to make this super complicated so that you can really test whether you know how to do this. Times 2 a to the 5th b cubed c to the negative 5th to the negative 2 over b cubed c squared, and then times a to the negative 2 b to the 4th c squared d over a b cubed c to the negative 2 d cubed. Hopefully my pen will catch up. And this will all be raised to the negative 2. Okay, we'll give a second for the... Sorry, I was just waiting for my pen to catch up. So this is b to the 4th c squared d over a times b cubed c to the negative 2 d cubed to the negative 2 power. Okay, this looks super complicated. If you can do this, you know you got it, okay? It's not harder, it's just longer, and that's something that's really important to understand, that longer math problems are not the same as harder math problems, okay? So first thing that we're going to do is distribute. That's what we always do. So this becomes 4 squared a to the 6th b to the negative 2 c to the 4th. So just be careful, because most common problem is people get confused. They forget that they're multiplying instead of adding and so forth. So just be really careful, because any mistake that you make in this first step is carried all the way through. So then we have over a to the 5th b times 2 to the negative 2, a to the negative 10, b to the negative 6, c to the 10, over b cubed c squared times a to the 4th, b to the negative 8, c to the negative 4, d to the negative 2, over a to the negative 2, b to the negative 6, c to the 4, and d to the negative 6. Okay, what did we do here? I'm sorry, I didn't put that in red. I'll put the rest in red. I forgot, and to rewrite it just seems like a lot. So what did we do here? We distributed the exponent. Okay, I'll write it on the other side instead. Okay, I'll write the rest in red. Okay, so remember that this is all like one fraction. So our next step is to combine it horizontally, right? So if we combine it horizontally, we have our 4 squared, and we see 3 a's. So the 3 a's that we see are a to the 6th, a to the negative 10, and a to the 4th. Just add them all together. 6 and negative 10, okay, gives us negative 4, and then plus a positive 4 is a to the 0. So it just goes away. A to the 0 just disappears. What I would do is I would keep it, because we have denominators. We have a in the denominator, so this a to the 0, even though we know it's equal to 1 and it goes away, it might, depending on how skilled you are, it might be helpful to keep it in there, okay? Then we have our b's. Negative 2 and negative 6 is negative 8, and negative 8 gives us a negative 16. So we have b to the negative 16. Then we have our c's. 4 and 10 is 14, and negative 4 is 10. Then we have our 2 to the negative 2. We could put that in there. Okay. Then we have our d. It's just d to the negative 2. Then we do the same thing on the bottom. So we have an a to the 5th and an a to the negative 2. 5 and negative 2 is 3. we have a b to the first, b to the third, and b to the negative 6. So 1 and 3 is 4, plus negative 6 is negative 2. A c, we have a c squared and a c to the fourth. That's c to the 6. And then we just have a d to the negative 6. There's nothing to combine it with. So what did we do? We combined horizontally by adding. Notice how quickly it turned into something that really wasn't so complicated. It doesn't look complicated anymore. So then we combine vertically. Combining vertically, we have a 0 and a 3. We subtract. So we can leave the 4 squared. Nothing changes. We get an a to the negative 3. We combine the b's. Negative 16. This was a negative 2. That negative didn't come out. 16 minus negative 2. Sorry, negative 16 minus negative 2 gives us a negative 14. 10 minus 6 is 4. And negative 2 minus negative 6 gives us a positive 4. So don't forget about this 2. So here, we combine horizontally by subtracting. Okay, so we want to get rid of negative exponents. This was a negative 3. Some of these negatives are not coming out. So, first of all, 4 squared is 16. So we may as well just write 16. The a cubed is going to go on bottom. B to the 14th goes on bottom. C to the 4th goes on top. 2 to the negative 2 goes on bottom. It's a 4. Okay, and I'll write this separately. Then d to the 4th goes on top. Okay, so I'll put this in. We get rid of our negative exponents. Okay, and over here, I'm going to write 2 to the negative 2 is 1 over 2 squared, or 1 over 4. And 4 squared is 16. So that's where the 16 and the 4 came from. The 4 is from the 2 to the negative 2. It goes in the denominator as 2 squared. And the 16 is 4 squared. So the only thing left to do would just be to simplify that. So 16 over 4 is 4. And this is our last step. So we just simplified. We call those constants. Sorry about that. So we could put that in. I'll put that in red. I'm writing the same thing. I'm just putting it in red. I don't want you to get confused by the colors later. And I'm just going to put here simplify constants. But I'll put meaning 16 over 4 is equal to 4. And let's just write that solution again. This is equal to 4c to the 4 d to the 4 over a cubed b to the 14th. Okay, it's not. Sorry, sometimes things don't come out. I'm just going to write it over here. 4c to the 4, d to the 4, a cubed, b to the 14th. And you will get extra practice on homework and on review sheets. Okay, that's a b to the 14. And that's it for today on this video. Okay.